Welcome. My name is Michael Wickerson, and I'm continuing with this parametric grasshopper series for the Rhino environment. We're looking into sets, and we're trying to finish up the sets, nodes, and the tree ribbon components. We're going to look at relative items to end this. You may notice a similarity in some of the offsets in comparison to the masks we were using with some of these other nodes like shift paths. So what I've done is I've gone back to using, I'll just turn this off so we can only see what we're looking at. I've gone back to generating a grid. I've used a bit higher number count of 4 on this one, and it's simply a series that is cross-referenced with one graphed on A to get a three-dimensional grid pattern of points. And the relative items is a tool that offsets whatever you want to take the paths. So take a look at your param viewer, slip it in here. Take a look at your format, just like you were looking at your what would happen within the path mapper. I have 16 items on 4 different paths, which make up these kind of, let's say, books or locations of books on shelves within this shelf system, this one, and this one. We can number them if we want a point count to see a point list to see where we're actually dealing, but I think you can understand it at this point just visually and hopefully at the param viewer. What you do is you take that tree and I'm offsetting it. I'm offsetting it initially by one number and what it's doing is putting everything to item A. It's been offset, so you get everything but this first column. That's been shifted in that direction, and then B are the items that obviously have shifted in this direction. So it's very nice to see how the relative items can play with different data systems. And because there's a kind of offset to each one, I can join those points together and end up with some very interesting geometries. And because line geometry is so good for kind of thinking about things, you can think of the points. And I've also done that with the visualization of the cones. What's in the B section and what's in the, if you're not interested in looking at points and you actually want to start rotating them, doing things like that singularly. So we'll come back to the lines. We'll see what happens to these patterns as we start to shift and select points differently. At times, if you want to see an object, obviously if I shift the indice count or the element count or offset it, I'm going to lose another one here. And then on the reverse end, it's going to shift it back this way, so I can take a look at the cones coming back in that direction. I can offset it by 3, and that's going to do the same thing to these cones and these cones. But I also want to do to see what that does to the patterns of the lines if you want to start to drive geometries by these really nice patterns. So let's go back to the offset of 1. Let's go to the offset of 2. Let's go to the offset of 3. Basically, we're using line and cone geometry to understand what's happening. If I do produce breps, then I do produce volumes. And if I produce volumes, I produce centroids. And those are a whole other series of points to do some wrapping and pivoting and positioning. So what I like about this one is I can throw in an offset to a 5 count pretty much in the middle. If I reduce my count back down to 3, you'll see that's exactly what happens as I start getting some control over geometries that everything below or above that point count has either been rotated by 1 pi or rotated by 0 pi. So you end up with these ones, and you end up with these ones doing a full 180 rotation. And you can start having some really good geometric control of what's happening. And that's what I find exciting about dealing in sets. Thinking of your geometries in multiples, thinking of dealing in lists, and starting to gain control of that. Let's jump over to another monster. It's a much bigger grid system. This one's a flat 2D grid, and this is a flat 2D grid planar, but it's been lifted up and lofted. And with those 2 bits of data, with different step counts on each one, and I believe everything else is the same, except step count stays the 4 here, and the other one is 5. I can find those points on the top and points on the bottom. You may want to reference top view and side view to get a sense of where you are geometrically. I'm not going to wrap my paths or do anything like that, but basically the data, grabbing the data on the bottom, grabbing the data on the top, put a line count between it, and then with the offset, we can start to move these counts to produce another 3D line geometry. And I've thrown it into a subdivision curve, which might be nice to see them all on their independent shelf, but starting to do things, and when they start to touch one another, the multiply really starts to fuse them together and build some interesting geometries. I've also put spheres at the ends just in case you wanted to join things. And you could always use a pipe or a variable pipe here. The radius of the sphere can be, on a very basic level, changed. So let's take a look at what happens when we roll it through a path as opposed to an indices. offsetting indices. Let's offset paths and see what happens. Well, these definitely, this whole system or path of this kind of what I think of as a shelf in a library, has got to jump. So let's jump it over by 1. And you see that's exactly what it is. This one came over here, this one moved, this string moved over to this one moved over to this one, and this one moved over to this one. Let's offset it by 2 in the paths or the branches, and you'll see the same thing that happens. Nice control, and of course it's fully parametric. You can come down and simplify what you're doing, and you can make it more complex. When they do start to cross over, like I said, the multi-pipe algorithm is pretty sweet for figuring that out. If you want to select the spheres as well to see what's happening, there's a little bit of a slowdown because it's generating those. Hoping it can crash out, but if I did, I'll end this video on relative item offsets. There we go. Just took a little bit, and if anything's slow like that on your sphere, just a little trick to do is to go in, double click, and do a mesh sphere, probably. I'm sure there's a mesh sphere. That's going to speed things up for you. Let's grab this geometry out to the base and change that radius here. And that should speed things up quite a bit. I'm going to delete that one and tuck that one into the add to group. And now when I select that, and that should be pretty fast moving as to what I'm doing as a piece of geometry with the mesh pipe. Really play around with your offsets. Start to understand as you change these things, how you're actually changing the data structure. And the param viewer will let you know, when you take a look here, that you're matching your elements or indices to your paths. And these paths stay pretty simple. If you're running into problems with these or you find them a little too complex because of what's coming in, you might want to grab a simplified tree. I'm just going to put that in for here because it changed the path. If you take a look at this one, it changes this to simplification. These don't work now because they're not written right, and this is another backed up problem with path mapper and shifting maths. And when you're using masks and offsets, this one has to be rewritten with just the singular item to match the data structure. And when that happens, you should be back into being able to write it like that. I don't think I'm going to do that because that's just going to confuse us. I'll come back to our original one that actually works. Not simplify those paths and just make sure that things are following what they're supposed to follow. Hope that's helpful. I'll spend a little more time on particulars, but once you get some geometries and some architectures going and you have multi-components that are referenced by points, and those points are referenced by point attributes, I think you'll want to gain more and more control of the sets. Once again, in the sets tool, in the sets tree tools, you want to get a handle of these, and once you manage these, 20% of these is going to lead you far into the future as to what you end up doing. Thanks very much for watching. 8 minutes on relative items and offsets. That'll finish up our set series, and we'll jump into vector nodes.